All right, let's take a look at even odds. So here, we're going to take a first look at sine. And we're trying to figure out if sine of negative x is equal to negative sine x. We go down to our unit circle. And let's see here. It looks like I picked 4 pi over 6. So if I go to 4 pi over 6 from 0, which we're always starting from here. And for positive, we're going to go that way. Negative, we're going to go that way. So we're going to wind up with 4 pi over 6 going around the circle positively, and we're going to get over here. And we're going to see that sine is root 3 over 2. We'll put that in green. Now remember that we made that one negative after we found the sine. So it's going to end up being negative root 3 over 2. We could also have gone the other direction. Remember, we could go negative 4 pi over 6. And that would bring us down and around here to negative root 3 over 2. So what we have found here is that sine of a negative theta, or negative angle, is equal to negative sine that same angle. Now we're going to prove that tan of negative x is the same as negative tan x. So again, we started 0, 0. We started 0 or 2 pi, depending on how you think about this initial point. And we're going to take a look at 5 pi over 6. So we're going to go around positive till we get to 5 pi over 6, which is right over here. And we're going to get 1/2 over negative root 3 over 2. So recall that tangent is sine over cosine, right? SOHCAHTOA, tangent is opposite over adjacent. So you need to recall how we actually created this unit circle with the special triangles. So we would get 1/2 over negative root 3 over 2. And we've got that negative on the outside. So we'll distribute that negative in a second once we clear up what's inside those parentheses. For our tangent of negative 5 pi over 6, then we're going to go around the other direction. And we're going to get to right here. That's going to be, again, TOA, opposite over adjacent, or in terms of unit circle, sine over cosine. So it's negative 1/2 over negative root 3 over 2. Now, I don't want you guys to get confused about what I did in this next step. This is just an academic version of copy.flop. Right? So when people say copy.flop, what they actually are saying is you multiply the bottom fraction by its inverse operation. Or you conduct the inverse operation of it. So you put, like, in this case, we had root 3 over 2 on the left-hand side. So we're going to multiply by 2 over negative root 3. Right, so all of that cancels out. The negatives cancel, the root 3's cancel, and the 2's cancel. What we do to the bottom, we must also do to the top. And that's going to end up being 2 over negative root 3, as we discussed on the bottom. When you do that, the 2's are going to cancel, and the negatives are going to cancel. So as you can see, if we had gotten rid of that bottom piece of this, that would look just like what you guys consider to be copy.flop. And then I did the same to the other side. What I'm going to wind up with is 1 over root 3 is equal to negative 1 over root 3. We're going to distribute that negative through. We're going to get 1 over root 3 is equal to 1 over root 3. Now, just as a rule of thumb, in math, we don't like having a root in the denominator, so we would multiply both the top and the bottom by root 3 to get rid of it. But in this case, all we were trying to do is prove that they are equal. So we could really stop wherever as soon as we find out that that's going to be true. So we proved that tan of negative x is the same as negative tan x. Next, let's take a look at cosine. So we're going to prove that cosine x is the same thing as cosine of negative x. So if I go from our 0 again, and I go up to pi over 4, or I go down to negative pi over 4. In both places, we see that is root 2 over 2. So this works out. Now, we ended up saying that cosine was an even function and sine was an odd. Right? We proved all three of these to be true. If all three of those are true, considering that the other three trig functions that we looked at are just inverses, right, 1 over, then these should follow these same principles, right? So cotangent is going to be odd, cosecant is going to be odd, and secant is going to be even. So in other words, I don't want you guys to have to memorize all 6. If you just know these 3 and understand how those inverses operate, you shouldn't have to do that. Okay, that said, that should do it for this one.